Hello YouTube, Ron this side. So in today's video, we will be exploring a new tool which is OPA Gatekeeper. So OPA Gatekeeper is a tool which is for creating policy and governance of Kubernetes cluster. So first we will understand what is OPA. So OPA stands for Open Policy Agent, and it is a open source general purpose policy engine that unifies policy enforcement across the stack. And in our case, we will be using a Kubernetes cluster. So it provides a high level declarative language that lets us specify policies as code and simple APIs to offload policy decision making from our software. And we can use OPA to enforce policies in microservices, Kubernetes, CI/CD pipelines, API gateways, and more. So, in simple terms, we can understand that OPA, using OPA, we will be writing policies and policies using the code, the YAML manifest code, and we will be enforcing those policies or imposing those policies inside our Kubernetes cluster so that whenever we will be creating or modifying a resource, so it should follow according to the policies where we have written the rules and regulation, it should follow. So, what is OPA Gatekeeper? So, OPA Gatekeeper is a specialized project providing first class integration between OPA and Kubernetes. So, OPA Gatekeeper acts as a bridge between OPA and Kubernetes, and it has the below components in its architecture. So, first is an extensible parameterized policy library. So, this library has all the parameters and all the rules, predefined rules, which we have to use. After that, we have native Kubernetes CRDs, custom resource definitions for instantiating the policy libraries, aka constraints. Then we have native Kubernetes CRDs for extending the policy library, aka constraint templates. And then we have audit functionality. So we should also ask that why we need gatekeeper. So if we are not using gatekeeper, then what issues we are facing? So you can assume that if you are a platform DevOps engineer and you are managing multiple Kubernetes cluster for various projects, so sometimes you will face challenges that users deploy applications or your teammates deploy applications without adhering to best practices. And you will also face some issues like lack of ownership unless users apply labels themselves, no resource limits leading to high cost, untrusted images impacting other applications, security and best practice violations across cluster. To address this, we need governance so that where we will be enforcing limits and rules via policies. And in this case, we will be using OPA Gatekeeper to ensure and implement those policies so that these can be followed across our Kubernetes cluster. So this is a architecture diagram of OPA Gatekeeper, and you can understand that inside Kubernetes cluster we have OPA, and OPA is inside Gatekeeper, and Gatekeeper is inside Kubernetes cluster. So this is how Gatekeeper acts as a bridge between your Kubernetes and OPA, and the API server is the one who will be mentioning or who will be storing the template CRDs which we will create using gatekeepers, which has the policies which our cluster has to follow. And after that, we have Kubernetes native resources like pod, service, config, ingress, and etc. After that, we have a auth set webhook and admission controller so that uh, our API server should first pass these two components, and after that the query will move to OPA. So in this slide, I have just written down the summary of the architecture which we just saw, and I will try to explain like what is a workflow. So you can understand that policies are defined as policy templates and instances in the form of CRDs, and they are stored in the API server. After that, our gatekeeper replicates these policies into OPA for processing. After that, during resource creation or modification, the admission controller sends an admission review to gatekeeper. Then our gatekeeper queries OPA to check for compliance, and based on the result, allows or denies the request. And gatekeeper also perform periodic audits of existing resources to ensure ongoing compliance. So in short, what you can understand that first you will create policies using policy templates and instances which will reside in our API server. Then those policies will be replicated by gatekeeper into OPA so that for extra processing. After that, whenever there is a request from user, then a Cube API server will fulfill that request from the user, and then according to that, it will start with a resource creation or modification, and our admission controller will come into act, and it will send the admission review to gatekeeper. Then after sending the query to gatekeeper from admission controller, then gatekeeper will send the same query to OPA so that it can check the compliance, and based on the result, our Kubernetes cluster will allow the resource to be created or modified, or it will simply denies or discard the request. And this is why OPA will replicate these policies which we have created in the first step. After that, gatekeeper also perform periodic audits for the existing resources which are already running inside our cluster so that it can check the ongoing compliance. So okay, so this was a slide which I have prepared for this demonstration. So for the same tool, I have created a simple GitHub repository as well, which we will follow across the demo. So here, the only main file which we have to understand is this constraint template. So here, what I have done is I have created a constraint template kind, and I have given a specific kind so that whenever any resource which has this kind, this custom kind, then it has to follow the constraint. Sorry, this kind will be attached to the constraint, and then that constraint should follow the rules which is written inside this constraint template.yaml, and the rules are mentioned here inside the target section. To be very honest with you all, I don't have much knowledge like how it is written, but I have taken the copy from the official GitHub repository of Gatekeeper. So I will definitely encourage you all to watch or fork that repository as well. So without wasting your much time, I will simply start with the demo. I will go with the playground, and as usual I will select the Kubernetes 1.31, and let us wait for the cluster to get up. Okay, so in the readme, first we have to install OPA Gatekeeper. So I have provided two options. One is using kubectl, and another is using helm. I will be going with the first one, the kubectl one. Then let's apply this. So it will create the namespace, resource quota, CRDs, RBAC, cluster role binding, and all other stuff required for this tool. Now let's check if everything is running fine or not. Okay, so everything is up and running. Now let us check Now, what I'm validating gatekeeper CRDs. Why? Because we have to use constraint templates dot template dot gatekeeper dot sh. Why? Because using that we can create constraints and constraint template to work with gatekeeper, because these two are the one which will help us to create a constraint for our Kubernetes cluster. So constraint templates define a way to validate some set of Kubernetes object in gatekeeper's Kubernetes admission controller, and constraints are used to inform gatekeeper that the admin wants a constraint template to be enforced or imposed inside the cluster. So let me just copy this, create a new file. Let me first clear the screen, then nano uh, ct.yml, paste this, save this, and move out of this. Now let me just apply this. Kubectl apply -f ct.yml. Okay, so this has been applied successfully. After this, we have to follow the next step. Now we will just list down the constant template which we have just created, and here you can see that it is created successfully. After that, what we have to do now, as we have applied constant template, now we have to apply the constraints, because these two work accordingly. So let me first create this file, where what I am doing is I am creating a custom constraint and using my kind. And what I want is I want that pod, whenever I am creating a pod, it should have labels, and the label should have app as the key. So let me just copy this, paste this, save this, and move out of this. Kubectl, then apply -f. Okay, it's created. And let me check the constraints. First we have a check the constraint template. Now we are just checking the constraints, and here you can see pod must have label. After that, now let us execute or create a pod. So here what I'm doing is I'm creating a simple weather app pod from my custom image, and here I'm not using any label. So according to the gatekeeper, the Kubernetes cluster should not create this pod, and it should discard. So yeah, here you can see that it has discarded, and error from server, admission webhook validation.gatekeeper.sh denied the request, and this is the constraint name, and it is stating that you must provide labels and the key should be app. No problem. Now we will use the same command, but we will be attaching the labels. Here you can see I have used this flag labels, and the key is app, and the value I am giving is test. So see, the pod weather app is created. Now let us just expose this pod so that we can check if the application is working fine or not. Okay, so the service is also exposed. Kubectl get svc, and this is the port given to the service, which is 31943. Let me open this. Okay, so I think it will take time, because I guess this React app is a little bit heavy, so it will take time for the rendering. Let me check if my pod is running or not. Kubectl get pods. Yeah, the app is running. Okay. Yeah. So yeah, here you can see mm, the app is up and running. Let me check for the London location. So yeah, it is providing the value, the data for the specific city. Okay. So yeah, we can consider that this application is working fine. So this is how we have like implemented the policies or imposed the policies for pods. Now let us go beyond pod and create a constraint for namespace as well, because we can use a number of uh, native resources which we can use for um, enforcing policies. So here also it is a simple YAML manifest file, which here I am creating a constraint, and this is a custom constraint name and namespace kind, and the label should have state key. Saving this. Now let me apply this qctl-fns. Yeah. Okay. So this is also created. After this, let us check the list again of the constraint. So now the result should be two. One is for namespace and another one is for pod. No problem. Now we will try to create a namespace name as test, and we are not providing any label. So Kubernetes should not create this namespace. So see, as desired, Kubernetes has discarded this. We can check the list as well, kubectl getns, and here we cannot see any test namespace. So to create the test namespace, I will just write this YAML manifest file ns test.yaml, and this is a simple manifest file where I'm creating a test namespace, and I am attaching labels which is state, and I'm giving value as dev. Now let me apply this, and it should create mm, yeah, it should create this test namespace. So yeah, namespace test has been created. kubectl get ns. Yeah, the namespace is active and running. Okay, so yeah, we have done the constraint enforcement for pod as well as namespace. Now let us just check the namespace. Oh, sorry, the constraints. Let me clear this. So yeah, here you can see enforcement action is deny, and total violations occurred is 6 for the namespace and 15 for the pod. So what you can do is we can also describe the constraints, the violations basically, according to the name of our constraint. So here you can see it has given us the result of the audit, and this is the name, creation timestamp of our constraint, then status, audit timestamp, and these many times violations has been occurred for this constraint. And yeah, here you can observe and watch that where the total violations or the violations has occurred for this constraint. So yeah, this was all for the video. I hope I was able to help you or able to explain you like how you can implement OPA Gatekeeper to secure and manage your Kubernetes cluster according to the policies you will enforce or impose, so that you will have a sync up for your resources inside cluster, and you can work on multiple projects according to the needs. So yeah, thank you, and have a nice day.